Hello everyone, my name is Sam Brewer and today we're going to be going over a Terraform CLI demo inside of Google Cloud. We'll be creating a VPC network, we'll be creating a Google Cloud instance. It is going to be a Debian instance we're going to be actually creating. We're going to be pretending that it's a SQL database. It's just going to be easier for demo purposes. And then we're also going to be creating a firewall rule, all of that with Terraform as well. There are some prerequisites that you need. The first one is obviously a Google Cloud project. So I went in and created a Terraform demo project here. As you can see, that's the name. You're going to need your ID for the project as well. It's going to be a big thing too, and we'll take a look over on that on the Terraform files here in a minute. Second thing you're going to need is more than likely you're going to need to manually create this. It's going to be a little bit easier. You're going to need to create a service account for Terraform. So I went ahead and created one, and I added a key to it and downloaded this JSON key. The permissions I gave it, if we see down here, I just gave it owner privileges. You usually shouldn't do that, FYI, but for demo purposes, I just gave it owner privileges so it has access to everything. Usually you want to create a service account for each infrastructure group and or person and give them the appropriate role and or permissions off of that as well, based on their role. So let's go ahead and take a look at the CLI. So I have a Windows 10 computer. I downloaded Ubuntu from the Windows Store. And then I went and started creating these directories, a directory tree and a branch and stuff like that inside, basically a repository inside of this Ubuntu. As you can see, I am in a directory called terraform-cli-demo. If I list what's in here, you'll see a README that's for GitHub. And then the other things, Terraform is installed on here. If we do a -A, you can see that there is terraform.terraform file in there. There's a .git file as well. Then the README is for Git. And then the other things are compute, networking, and security. So if we just do a regular ls, you can see compute, networking, and security are folders inside of here. So these are for each infrastructure group for what our project is doing. We're going to be adding a compute instance, which is hence the compute directory. We're going to be creating a VPC, hence the networking directory, and we're going to be adding a firewall rule, hence the security directory. All of these are infrastructure departments and or groups, and this is how the best practice is for Terraform or the cloud or whatever the case may be. This way you can give appropriate access to those team members so that you don't have them all into one and everyone has access to everything. The security people have access to modify the security directory. The networking people have access to modify the networking directory, and so on and so forth. So first things first is I want to go into one of these directories, kind of show you about it, and then I want you to understand that a lot of these directories are the same thing. Just the Terraform main.tf file is different. So let's go ahead and jump into networking because we're going to need to build our VPC first. So let's go into networking and do an ls. You can see that I have a credentials.json file that's inside of there. That is the service account JSON key that I downloaded on my computer and then copy and pasted everything into that file. This is what we'll be using in the provider block to call upon authentication for our project. So all these provider blocks are the same inside of each directory, networking, compute, and security, because it's going to be the same project, same thing. So let's take a look at that real quick. This is the only time we'll look at it. Provider block for Google. This is just a resource block, taken off of HashiCorp's website for Google Provider Block. My project is this project ID here, so I was saying you need a project ID. Make sure you note that down. I'm going to be doing it in a region US Central 1. I have my credentials, which is this credentials.json file that has all my information storing for authentication methods for that service account I created earlier. And then it's the zone that you're in as well. You don't have to specify the zone, I don't believe, but I just did anyway because I like to. So let's go ahead, let's head on out of here, and then let's take a look at the main.tf file that's in here. This is really simple, a really easy VPC creation method. I have the resource block for creating a VPC inside of Google. My project is that project ID. The name is going to be terraform-demo-vpc. That's what the VPC is going to be called. And there's a little setting here called auto create subnetworks is true. What that means is if you log inside of Google Cloud and you usually go to the VPCs, you'll see a default that has a default VPC that has a CIDR range for each region. It's going to do the same thing here. So US Central 1 is going to get its own CIDR range, private CIDR range at 10 dot range. Europe, Asia, all of those are going to get their own CIDR ranges based upon this little resource right there, that little block, and it's going to be true. So let's go ahead and let's head back. And let's just verify real quick. Let me clear that out. And let's verify that there are no VPC networks inside of Google Cloud. So if we head over here, go to this VPC network deal, and then we can see there are no VPCs. Let's go ahead and create this, shall we? So we're inside of here now. We're inside of our CLI. Let's do a Terraform apply. And it's just stating that the VPC will be created. We just went over that in the main.tf. This will take around 30 seconds to create. So what it is doing now, it is taking a look at that provider block that we already did. We did a Terraform init before we started on this, before I showed you guys. So it has everything necessary to reach out to Google Cloud. It has a service account attached to it because it's calling upon that file that I created. It is then going inside Google Cloud and authenticating. We're in, and it's creating the VPC and creating all the subnets based upon this. This should take 30 to 40 seconds. This should finish up here soon. And it did. So now those subnets in that VPC is created. We should, if we refresh the screen, we should have all these subnets inside of here. And we do. We have a Terraform demo VPC, and then 34 different subnets for each region that Google Cloud has. This one right here is the only one you need to worry about, though, US Central 1 region, this subnet, with a 10.128.0.0/20 CIDR range. And the gateway is 10.128.0.1. So when we build our first VM, the only thing that it'll grab from is US Central 1, because that's where we're going to build our VM in that region, that instance that we're talking about. And it should grab a 10.128.0.0 address. It should be 10.128.0.2 because the gateway is being used. So let's go ahead. Let's create that instance. But let's verify there are no instances in here first. If we head over here, there's not. There's not an instance. So now we're in networking. Let's go ahead and let's get out of here. And let's go ahead and go into compute, because that's where we're going to be creating our instance. If we do an ls, you'll see the same thing. Credentials. We have a provider block. It's the same exact thing as it was before. Let's take a look at the main.tf and see what's inside of here. Same deal. We have a resource block from HashiCorp that will reach out to Google and grab or start creating a Google Compute instance. My name for this VM is going to be Terraform Demo. It's an E2 medium. It's going to be built in US Central 1, but this is the zone, US Central 1-A. We're going to apply a tag to it called SQL-DB. We're going to pretend that this is a SQL database, a Windows server, even though it says Debian Cloud, Debian box here. Ignore that. We're going to act like this is a Windows box. For demo purposes, this is one of the easier things to create. It gets a little more complicated once you start installing Windows. So our network here is Terraform-demo-VPC, that one that we just created. And then we're also going to give it a public IP address too. That's just kind of a default setting that's inside of there if you ever need to grab updates or grab any software from the internet. But for the time being, it's going to grab both of them, but it's going to grab an internal IP from that VPC that we just created, and it should grab a 10.128 address from the US Central 1 region. So let's go ahead and let's exit out. And let's do a Terraform apply. We just took a look at this at the main.tf, so we understand everything in there. This should hopefully only take 10 to 15 seconds to create. I'm going to guess 12 this time around, so we should see it pop up here in a second that it was created. Still creating, 13 seconds. I was one off. I'm highly disappointed in myself. Let's go ahead and take a look. Refresh the VMs page, and we'll see that we have a Terraform demo VM now in US Central 1. It has an IP address of 10.128.0.2, so that is correct. A pull from the US Central 1 region and grab the next available IP in that slot. Let's take a look at this Terraform demo VM really quick. It has everything that we asked for. It's an E2 medium. It's inside of US Central 1. If we go ahead and scroll on down, we'll see it has a tag of SQL-DB, which is what we wanted. We're going to pretend this like this. I was saying this is a SQL database. And then it's attached to the Terraform demo VPC of that IP address that we talked about earlier. So let's go ahead. And now what we need to do is now we have a VPC created. We have a instance created, but we don't have any way to access this instance. So this, what we're saying this is a database inside of Google Cloud, and we have on-prem application servers that need to access this database inside of Google Cloud. You have an interconnect set up or some kind of partner interconnect to where you have private routing back and forth via across links between your data center or whoever the case may be. So this is all going to be internal. So now we have a subnet zone, a security zone inside of our data center. That's ours. That's a 10.0.0/24 network, or 10.0.0.0/24 network. That guy will host all of our application servers. But all these application servers need to access this SQL database. Right now it can't because Google Cloud is blocking that. There's nothing that's allowed to view that instance or access that instance. If we take a look here, there's a firewall. You got to remember that Google Cloud firewall is denied by default, and then it'll allow as you add. So let's go ahead and add a firewall rule for the CIDR range at 10.0.0.0/24. Those application servers will be coming inbound to the Google Cloud Firewall and that SQL database that we just created. And we'll make sure that's on a port 1433, which is the SQL port. So let's go ahead and let's create that firewall rule. So I got out of networking or compute and I went into security, that infrastructure group. So if we do an ls, same deal. We have main.tf, a provider.tf, and a credentials. Credentials and provider are the same, but let's take a look at the main.tf, shall we? So let's take a look. And here we have the resource for Google Cloud Firewall from HashiCorp's site again. It's super simple. You just pretty much copy and paste what you want inside of there. I'm keeping it really basic. We're going to allow ping inbound, and we're going to allow TCP 1433 port inbound. Obviously, direction is ingress, so we're going to keep it as ingress. The source ranges, this source is going to be coming from that CIDR range there of 10.0.0.0/24, where our application servers live on-prem. The target tag for this firewall rule is going to be SQL-DB, which is what our target tag is that we gave that VM when we created it. If we take a look up top, we're going to call this SQL-DB access, and it's going to use the network Terraform-demo-VPC that we also just created. So let's go ahead, let's exit out, do a Terraform apply. And last time I tried to do this demo, it took a little bit longer than it should. It said it was completed, but it never popped up inside of the console until about a minute later. Hopefully we get an immediate result this time, so I'm trying not to awkwardly fill silence, right? So sweet, it says it was created. Let's head back over to Google Cloud. I'm just going to go to VPC Networks and then go back to Firewall. It will take a second. It did this last time as well. Let me go and refresh. This one's taking a bit. There it goes. So now we have it and it's created. Like I said before, it's the name of SQL-DB access. The type is inbound, so it's ingress. Targets is a SQL-DB. The source is going to be this 10 dot range that we have for our on-prem application servers on TCP port 1433. We're going to allow this and have a basic priority of 1,000. We didn't specify this, but for this time, we don't really need to worry about that. And this firewall rule is attached to the Terraform demo VPC. If we go inside of this SQL database access firewall rule, we scroll down, we'll have a applicable to instances section, and we'll see that our Terraform demo VM is attached to this firewall rule. The reason being is because of this tag. If we go back to the Terraform demo VM and we view this real quick, it's going to switch over to the compute engine. There we go. And we scroll down. There's that tag. If we didn't have that tag, that firewall rule would not have been attached. So now that we have it attached, now our application servers can access this SQL database and grab the data that it needs to. And now we're fully functional and running. That was a very quick demo on building a VPC, creating a VM, a SQL database inside of that Google Cloud Console, that VPC that you created, and then attaching a firewall rule to it to allow that connectivity on that port. Thank you very much, and if you have any questions, please feel free to leave a comment. Thank you.